Okay, so here we go. When you're given an outcome table, guys, you do not include what's like you want to kind of go 1, 2, 3, 4, 5, 6. If it's a 6 by 6, right? 2 6-sided die or dice. Sorry, if it's like the colors we did yesterday, 4 colors and 5-sided die, right? Like so, it'd be 4 times 4. There are 16 outcomes. Like that should be clear, right? 16 outcomes. So I will already just do the sums because that's easier. It's easier to see if you do that. Okay, so I fill in the sums. That would probably be worth marks, obviously. What's the probability of rolling a sum of 5? Okay, sum of 5 is right there. So it's usually in a diagonal. Things in an outcome table with dice is diagonal. Like that's where you're gonna find them. So you have 4 instances out of 16. That ends up being 0.25, right, or 25%. If you have the fraction there, I'm very happy today. I won't go any further. 4 out of 16, we're good to go. Probability of a sum of 3 or 7. What's going on with the or, guys? You probably don't like that, right? It's like, what am I supposed to do with that? Well, here are your 7s, and here are your 3s. And or means either one. You're actually getting a better chance if that's the case. So sum of 3, right? There's 2 out of 16. And sum of 7, in this case, it happens to be 2 as well. So that's actually 4 out of 16, which gets you to the exact same answer as in B. Right? It just happens to be the case. I could have said sum of 4 or sum of 3, right? I could have done anything. So keep that in mind. State the probability of sum. This one I didn't cover yesterday. I know that. A sum greater than 6, which means it has to be bigger than 6, obviously, right? 7 or higher. So I'm going to circle that. So you have greater than 6. This is your 6th line. So these ones here, right? These ones here represent all the options that give you a sum greater than 6. So we've got 3 out of 16 there, which is 0.1875, which is 18.75. How are we doing so far? Your brain is probably like, I hope now that you've tried it and then now that you see it, you're like, okay, I see where this is going. That's what I'm hoping is happening in your brain here. Okay, next. Wording, guys. Wording. I saw a lot of you miss this. 5 out of 28 will be late, right? On any random day. What's the probability of being on time? Did you catch that? So 5 out of 28 are late. That means that 23 out of 28, right? You subtract it. You take the 5 away from the 28, and that gives you the 23, right? 28 minus 5 is how I got that. And that gives you 0.8214, which is 82.14%. Okay? How are we doing? We're doing okay? But keep going. Again, wording here is going to be crucial. So you're rolling a 12-sided die, right? How many times are you tossing it? It's like spinning the wheel, right? Earlier, 23 times. If you haven't bought into the highlighter, right? I've told you, get your highlighters. And you rolled a 9, how many times? 5 times. There's a lot of things going on there. Okay? What's the experimental probability of rolling a 9? Okay? Probability of rolling a 9. In terms of the experiment, what actually happened, you rolled it 23 times. Okay? That's where you get that. And how many times did you get a 9? 5 times, right? So it's it's here, and I'm getting all confused here. Yeah, orange, right? See, that goes there, that goes there, and you're like, what about the 9? Well, that's what we're after, right? The probability of that happening is 5 out of 23 times in terms of, we want it as a decimal, correct? So we're going to go 0.2174. Okay. Theoretical probability of rolling a 9. What do you think? This is experimental. This is theoretical. 1 in 12, right? There's only one 9 out of the 12 options. So that's where the 12-sided die came in. It tells you, it helps you for your theoretical, to, right? That's where you use that. So I will, it doesn't show up on the experimental, but it does show up in your theoretical. Decimal 0.0833. Okay. Theoretical probability of not rolling a 6. Right? Remember the writing, this is how you write it, not rolling a 6. That would be 11 out of 12, right? Like it's 11 out of 12 times where that happens. It says fraction only, so we'll leave it like that. Okay, so the 12 again, because it's theoretical, we use the total possible options, not trials, right? No trials. Can I put that down here? Trials. Okay. Explain why the answers in A and B are different. What can be done to make them similar? Make a reference to keywords, right? So you could say something, Fiona's sample size, right? Number of rolls is too small. That's the problem with it, right? She needs to increase the number of rolls. I know some of you are probably laughing right now. Don't want rolls. But anyways, increase the number of rolls. And that way to have theoretical probability be similar to experimental probability, right? Like that's what I'm trying. So if something is worth 2 marks, don't just give me 3 words, right? You like expand. Like let me see that you're understanding what's happening here. And next is the polling question. So 100 people are being surveyed. That's the problem right there. I don't know if you caught it. 100 people have been asked, hey, who are you going to vote for? NDP. Okay, therefore, NDP is going to win the federal election. Right? We're talking 30 million plus people, right? So again, not accurate, right? The sample size, which is the number of people polled, right, is too small. Considering a population of 30 plus million. Okay, something like that. Relative to like 100 people for Sisler, like if they, hey, who are you going to vote for in next student council election? 100 people for Sisler would be okay, right? 100 compared to 1,800 students, it's okay actually, but not compared to the country, right? Next page. I better get going here. Cards are easy, right? I shouldn't say that. Some of you might struggle, but I'm just saying they're faster if you know what you're doing. A face card of spades, right? Spades is a whole suit. There's 13 cards. And out of those 13, 3 are face, right? So 3 out of 52. We'll just leave it like that. A black ace card, there are 4 aces, but only 2 of them are black, right? Drawing a jack, we've got 4 out of 52 that are jacks, right? We're just going to leave it like that for today. Keep going. Let's do the marble, or the M&M, sorry. I should tell you this. Dice, cards, marbles, classic probability questions. Sure, we will turn marbles into candies or whatever, but it's the same thing, right? So just familiarize yourself with those, and you'll be okay. Spinners are good too. We like that. Okay, and Mo opened a bag of 120 M&Ms. So I'm going to highlight that. That's my total, right? And you've got some yellows, reds, greens, and then the rest are brown. I already did the math, right? 120, subtract those, you end up with 41. So I'll just put that down already. I have a feeling it's going to be handy, right? The probability of randomly pulling a red M&M. So probably a red, we've got 24, and we've got a total of 120. That ends up being 0.2 or 20%. Nice and easy, right? Probability of randomly pulling a brown M&M, that's why it's worth more, as you can tell, because you have to figure out the 41. So that'll be 41 out of 120, which ends up being 0.3417, which is 34.17%. Am I talking too fast? You can watch the video later again and slow me down. How's that? What's the probability of randomly pulling an M&M that is not green? Oh, you need to watch out for the not green, right? So we have 120 minus, let's take away the greens, over 120. When there's a not, this is usually what I do. It's easier than figuring out, oh, what are the other ones, right? Just take it away. And so it's 101 over 120. And that's 0.8417. Almost there, guys. Almost there. Okay. I hope you write this down. If the distribution is the same, how many M&Ms could you expect to have in a bag containing 1,200 candies? You already know what this is, right? I hope so. I hope this is like, yeah, make a prediction. So probability of red, I already calculated it up there. I'm going to use this one that I didn't, right? You didn't simplify or anything like that. And you multiply by 1,200 candies. You get exactly 240 red candies, right? Okay, finished. This is the finish line here. Do you remember sticker price? I hope that's on your study sheet. Is it? I don't know. I started my third one and I forgot about vehicle finance, right? Well, don't do it, right? Build it. Build it. Sticker price is, let's do that right here. Sticker is base or MSRP, right? Options plus freight. Yeah. Transportation. Yeah, there we go. And possibly documentation fees, but that was just the one question. I pretty much got rid of all that. And so we have, if you add it all up, I add up all those things and I get 37,049. How's that? We're good? I was kind of rushing. Is that what we're getting? I get nods. More than one nod? Yes, one mark. Purchase price after tax. So this is a new vehicle. So we go 37,049. We got to take away that down payment. Right? Remember? You take down the down. Wait. That was a trick. I now remember. I tried to trick you that you don't take away the down payment. You only do that if it's a trade-in. If it's a trade-in, you need to subtract before adding taxes. But you can't say, hey, I'll give you 4,900, take that off and then put taxes on there. You can't do that, right? Right? You don't go to a superstore. It's like, hey, I'll slip you 50, take that off and then add taxes to the price. You can't do that. So there, that's all you're supposed to do there. Where's the down payment? Where is that going to be a thing? When are we using the down payment? Do you remember? When we do financing, do you remember loans and stuff like that? That's not fair, right, Mr. Dixon? It's been like months ago. Why would you do that to us? I almost fell for it. So you got to keep this, so no big deal. I need to figure this out here. 3749 times 1.12. That's 41,494.88. But remember trade-ins? Yes. If you have your formula should call for a trade-in. This is not a trade-in. It's just a down payment. Okay. Depreciation. You take, which price would you take to figure out depreciation? The answer is the MSRP. Yeah. Also not fair. Oops. I did talk about it, but it's been a while, right? So this is 5235, but they want the value of the car after 1 year. So it's 34,900 minus 5235, which is 29,665. You get 1 mark at least. If you use the wrong number here, I would still give you at least 1 out of 2. Okay. Last but not least, interior angle. You remember that one? N minus 2 times 180 divided by N. That's 171.22 degrees. That's you. You get to keep this one, because I will give you a copy, okay?